If you connected any type of peripheral device to your computer, then you've probably used a USB cable. USB stands for Universal Serial Bus, and it has become the standard connection type for our keyboards, our mice, and almost any other device that we would directly connect to our computer. One of the first versions of USB was USB version 1.1. It had two different speeds that it operated at. One was what they called low speed at 1.5 megabits per second, and another at full speed, or 12 megabits per second. We generally saw 3 meters in length as the cable types for low speed and 5 meters in length for full speed. USB 2.0 was a significant improvement to the throughputs of USB, and it had a maximum of 480 megabits per second, again over a cable that was approximately 5 meters in length. And USB 3.0 is a standard they call super speed. It operates at 5 gigabits per second over approximately a 3-meter cable. We say approximately with these cable types because the USB specification does not specify an exact cable length, but generally speaking, these cable distances are about the maximum you can get and still maintain that level of throughput. There have been some updates to USB 3.0, including USB 3.1, which has a maximum of 10 gigabits per second, and USB 3.2, which has a maximum of 20 gigabits per second. The cables and connectors used for USB are relatively common, and you've probably seen one of these types of cables before. For USB 1.1 and USB 2.0, we used these cable types. Many of us are familiar with the standard A plug. It is a plug type that we continue to use today. If you're plugging in a peripheral, such as a printer or an external device, you may be connecting with a standard B plug, which has a bit more of a square type connector. And then if you're connecting a mobile device, it's probably using one of these smaller connector types, such as a mini B plug and the micro B plug. For USB 3.0, the connectors were changed just a bit, although the standard A plug has the same form factor as the previous version. The standard B plug was updated just a bit. You can see it is a little bit taller than the previous version, and the micro B plug for USB 3.0 is a very different form factor than the micro B plug we used for USB 1.1 or USB 2.0. As you can see, we've used a lot of different connector types for USB through the years, and we realized that we needed to standardize on one single format. We also needed a connector type where you didn't have to plug it in any particular orientation. The connector type we created is called USB-C, and this cable is one that can effectively replace all of those other USB connector types. This USB-C connector is a description of the physical interface that you would connect to a particular device. It does not describe the type of signal going over that particular connector, and there could be many different kinds of signal that you're putting through a cable that is ultimately connected with a USB-C connector. Side by side, we can see that the USB-C plug is very similar in size to the micro B plug, and you can see it next to the standard A plug so that you can get an idea of what the differences in size might be. Before we had the universal serial bus, we had simply a serial cable. Serial cables had many different styles, connectors, and formats, but two of the most popular were the DB9 and the DB25. The standard size of DB9 refers to the size of the connector. The 25 is referring to the number of pins. So the B-size connector is this longer size, and technically this smaller connector is an E-size connector. This would be a DE9, but since we were already using the term DB for the 25 pin, we kept the DB name and refer to it as the DB9 connector. But if you're ever purchasing an older serial cable, you might see it referred to as both DB9 and DE9. These types of connections sent signals using a standard type called RS-232. That stands for Recommended Standard 232, and it's been a standard for sending serial information over these wires since 1969. Remember that we were using these types of serial connections well before there was USB, even before there were standards that were in place for mice and keyboards. So back in the day, if you were connecting a modem, a keyboard, a mouse, or some other peripheral, you may be connecting it using one of these standard serial cables and serial interfaces. If you're using one of these DB9 connectors these days, then you're probably connecting to legacy equipment such as an older switch or an older router. This allows you to connect to the serial or console port on those devices to be able to configure them. Many of us don't even have a DB9 type connector on the back of our computer any longer, and we've had to convert between the newer USB-C connection to something like the older DB9 connection. If you were to look at one of those older switches or routers, you would see there was a console port. This particular console interface is an RJ45 connection, but it's not sending Ethernet through that particular cable connection. This is instead sending serial information. You might also find console interfaces that are DB9 connectors, and some of the newer switches or routers may simply have a standard USB connection. The reason we need one of these serial cables and we need to use the console connection is that this is one of the best ways to connect to this device when no other method is available. If there's problems connecting to a device through one of the existing interfaces that are on that switch, router, or firewall, you can always connect to the console connection through a serial interface. And if you're connecting to the console using this serial interface, you're probably put at a command prompt and you're typing in commands at the keyboard to be able to configure that device. And since most of our modern devices don't have DB9 connectors, but they do have USB connections, then we usually will carry around some type of adapter cable that will convert between the USB connection to a DB9, and even from there we can convert to the RJ45 just so we're able to connect to one of these console connections. Another method of connecting to a peripheral is using a standard known as Thunderbolt. Thunderbolt is a high-speed serial connection that has data and power on the same cable. This makes it very easy to power a peripheral device through a single cable that's running both the connection for data and the connection for power. The early versions of Thunderbolt chose to use a standard interface that was already available on many systems. This is a mini DisplayPort connector, and it was used with Thunderbolt 1 to provide 2 channels of throughput at 10 gigabits per second per channel. This obviously allowed a total of 20 gigabits of total throughput using Thunderbolt version 1. Thunderbolt 2 improved on that throughput by increasing it to 20 gigabits for aggregated channels, and you can see that it still used the mini DisplayPort connector. If you're connecting to a modern device using Thunderbolt, then you're probably not using the older style mini DisplayPort connector. Instead, we're using that newer standardized connector, the USB-C. This is a good example of how this USB-C plug can be used for many different purposes. And for Thunderbolt 3, we're able to get 40 gigabits of aggregated throughput using that USB-C connector. Thunderbolt 3 supports a maximum cable length of 3 meters if you're using a copper cable, but it also supports optical connectivity up to 60 meters in length. And Thunderbolt allows you to daisy chain devices from one to the other. So you don't have to have all of the devices directly connected to the computer. You could have the computer connect to a monitor, have that monitor connect to another monitor, and have that second monitor connect to an external storage device. Thunderbolt 3 knows what devices are connected in that chain, and it knows exactly what device to be able to send and receive information from. The newer Thunderbolt 4 standard still provides 40 gigabits of aggregated throughput, but it improves its video output to support dual 4K displays. This also increases bandwidth to the PCI Express bus, allowing much more data to be transferred from the motherboard to these peripheral devices.